Is it on?
Mm-hmm.
Hi, I'm Mr. Small. Today we're going to be talking about the standard form of a linear equation. It's different than slope-intercept form. You know slope-intercept form as y equals mx plus b. You can see that this is a little different. This is where you have ax plus or minus by equals c. So where a, b, c are integers, which means they're positive whole numbers, and they're opposites, it's like 1, -1, things like that. So they're not fractions or decimals. A and b are not the number 0, okay? Things that are similar about this to slope-intercept form. Some of my students have already commented on this. We've got an x and a y. We've got an equal sign. Things that are different. There are 1, 2, 3 numbers. These a and the b and the c will be numbers when you see the equation actually written. This is a generic equation instead of 2 numbers. And the standard form doesn't exactly show us anything about the line of the linear equation. What it does is kind of model real life scenarios. So let me show you some examples. If you're taking notes on a note sheet that I have for this, you would not see this exact stuff on there, but you can look at the questions, the 3 questions that are there, or the 3 spots to do anything you need to. So I'm going to show 2 examples. Let's say that you sold a total of $40 worth of tickets to the private screening of Aladdin Jr., which is happening this week at the school at which I teach. What are the possible combinations of tickets you sold? So what happens here is you've got different pricings for different types of human beings coming to this. You've got $4 for adults, you've got $2 for children, and then obviously you pay per amount of human coming. So the first thing you want to do is you look at this scenario. You've sold $40, and what you can do is you can write a standard form equation from this, given that there are 2 different types of tickets sold. So you want to write an equation that relates x to y if the x means the number of adult tickets and y means the number of children's tickets. What I would write is 4x plus 2y, and it's plus because we're adding the 2 prices and the amount of tickets purchased together to get 40. Okay, now I can complete this table showing the different combinations of tickets I might have sold by plugging in numbers, right? And then kind of doing the math here. So if I sold 0 adult tickets, which let's be honest, that's probably not realistic because children probably come with their adult people. But anyway, if I did, let's say I did sell 0 tickets, going back, I'm just doing this mentally. This cancels out. 2y equals 40, so I would have sold 20 children's tickets. Okay? Thinking about this further, I don't know. I guess I could I sell 1? I could. If I were to sell 1 children's or adult ticket, that would be 4 times 1. Take away that, so 36. I could sell 18 children tickets. Okay, we can continue with this. I might just go ahead and do like, could I do 10? I sold 10 adult tickets, and this is just a think aloud. 10 times 4 is 40, so the number of child tickets I would have sold would be 0. So actually, these are the 2 most important things I've just found. I found one of the intercepts and the other intercept. This is using language from slope-intercept form, the x and y intercept that I can plot, and then I can find combinations in between. This is the y-intercept, and this is the x-intercept. I know that because I know about my zeros with that. So, plot the points from the table. I only have, the 2 is the only, I have 3 points like I should. I'm going to plot 0, 20, way up here. I'm going to plot 10, 0 down here. I'm going to connect my line. Okay. In this case, it's going to be a line segment actually. Okay, so we'll deal with those, and then you notice the slope is negative because it's going to go down from the greatest possible combination of y, of whatever I have for y. And then if you look, you can kind of see some of the points along the way as they intersect here. Okay, so I've plotted those. The pattern is that as I sell 2 adult tickets, right? Or as I sell 2 less children's tickets, I sell 2 more adult tickets. Those of you who are with me are thinking about this in terms of slope. All right, you should be. The slope is given to us here. 4. I messed up. As I sell 4 less children's tickets, I sell 2 more adult tickets. The slope is down 4 over 2. The slope is a negative 2 is what's happening there. So you can kind of see how they relate. You can find slope. The slope-intercept form, by the way, then would be y equals negative 4x plus 20. This question asks me, if you find out how many adult tickets you sold, can you determine how many tickets you sold? Yes. That's the idea with standard form. You can still plug in and solve. So if I want to know if I could, let's say I wanted to see if I sold 4 adult tickets. I go up here and I use this. 4 times 4 is 16.
Excuse the interruption.
40 minus
Albert Yesep
16
and William Belisco, please come to the main office.
24.
Albert Yesep and William Belisco.
24 divided by 2 is 12. So I would have sold 12 adult or children's tickets, which is true. Oh boy. Okay, so that's using standard form. One particular way to use it. You could use the equation all by itself, and I only turned this into slope-intercept form after the fact. All right. Another example. You bought a total of $24 worth of cheese. You must have been having a party, I guess. What are the possible combinations you bought given the prices? So we got cheese for sale, we got Swiss and cheddar. It's an expensive cheese place, looks like here. You spent $24, you had 2 types of cheese to choose from. So there's some combinations therein. Okay? Everybody say fancy cheese.
Fancy cheese.
All right, here is the representation of what I might have done if I had this scenario. 6 pounds times $6 per pound times pounds of Swiss, etc. The standard form would be 6x plus, because we're adding these together, plus 3y equals 24. All right, there we have it. Now, what is that? Is again the same thing that this relates x and y. It's an equation in standard form. It fits the generic scenario. There's my A. All right, there's my B. There's my C. None of them they're all integers. In this case, positive whole numbers. They aren't 0. It's good to go. What we can also do with standard form is just what we've been doing this for a long time. My students have, that is. They know how to change this, well, I hope they do, into slope-intercept form. So it says write the equation in slope-intercept form, then we can graph it, which will probably be the most preferred way to do this. So I could take this, 31, 24. I could use my inverse operation knowledge, getting y, positive y that is, all by its lonesome is my ultimate goal. So then my equation in slope-intercept form is y equals 8 minus 2x, which would also be written as y equals 8. So the rate of change would be -2. Rate of change or slope. That's another way to say that. Rate of change. This is the y-intercept. And what I can do is I can graph this, and then I can talk about the possibilities of the fancy cheese shop, Swiss and cheddar that I bought. So at 0, 8, okay, what I have is, and this is the y-intercept, I have bought 8 pounds of Swiss cheese, meaning I have bought 0 pounds of cheddar, given the scenario. The slope tells me to move down to over 1. So if I buy 6 pounds of Swiss cheese, I have 1 pound of cheddar that I could have bought, given that I only spent $24. Down to over 1, again moving. So I began with the y-intercept, I'm moving using the slope to graph this, down to over 1, down to over 1. So at the end of this, I've got the possible combinations herein, this may not really connect unless unless the if I can buy half pounds of cheese, that's okay. Like I could actually connect this, but if not, really there's not a connecting line that goes through it, which I have to go back and amend that first thing. But all in all, what I know is that if I bought, and this is me summarizing the gist of what happened in this problem, if I bought 0 pounds of cheddar, I could buy 8 pounds of Swiss. If I bought 4 pounds of cheddar, I could buy 0 pounds of Swiss, and then these are the combinations that I could buy between them. So, excuse me, to summarize standard form, what we have is we can find the y-intercept and the x-intercept pardon me, using standard form. Okay, just using the equation as it is. What we would do is we would plug in 0 for x to find the y-intercept. To find the x-intercept, we plug in 0 for y. Then we could graph it and kind of show this in between. Really, by the way, this will not be connected because this is what's called a discrete domain, which you don't need to know yet, but just kind of amending that from the video earlier. We could also turn the equation into slope-intercept form, graph it, and determine the possible combinations. So in the end, I hope this helps you understand a little bit about what you're doing with standard form. You're going to practice a little now in the classes. So everybody say, standard form rocks.
Standard form rocks.
Okay, thanks. Bye-bye.